Okay, in this video, I'm going to show you how to get the induced charge on the total space E of the fiber bundle. So we're going to have two charts. One is open set V psi 2 on the fiber F, and the other one is U psi 1 on the base manifold B, uh, such that there is a local trivialization U, comma, phi, where phi is the homomorphism. Then the induced charge on the base on the total space W is a subset of E. E is a total space, and the induced charge omega, okay, where this big W here uh, is a preimage of the homomorphism of U cross V. U, of course, is a subset of the base manifold. V is a subset of F, and then the mapping omega on E, where E is an element of W, which is in the total space, is given by these two factors. So think of the theorem that we proved from last video. Omega is F, and then on this side here is F1 and then F2. Okay, so it's mapping into products or parameterized curve in a two-dimensional manifold, if you want to view as that. Again, E here is an element, generic element of W in the total space, and the dimension of B is equal to N, and the dimension of the fiber F is equal to M. Later on, you see in the case of the tension bundle, they will both have the same dimensions. Okay, am I right? The total space, or the open subset of W and E in the middle. And then I'm going to draw the bundle projection operator pi onto some open subset of U of subset of the base manifold. And of course the P is going to be an element of that U. And then of course if you had the chart psi 1, then you could just map it down to Rn in this case. So I'm going to draw in your Euclidean coordinate system Rn. You see the axis right there. And then I'm going to draw the omega, which is the induced chart. This is analogous to F of A in our previous theorem from the last video. And the total space here is R to the N plus M, because the dimension of F, the fiber, is M. Okay. And I'm going to go to the top is the homomorphism or the diffeomorphism, depending on the structure of the manifold. It's going to split the total space into U, Cartesian products of V, which is some open subset of the fiber. So I'm going to draw in the projection operator PR1 to go to the left, back to the base manifold. There we go. So PR1 is just mean that it's getting mapped to the first factor. And then of course PR2 is getting mapped to the second factor, so it's going to map out the V. So V over here is going to be a subset of the fiber. And then of course V is open in the fiber, so there's a chart side 2. So that's going to take you down to the Rm, Euclidean space. Oh, there you go. There's projection 2. I'm just going to go ahead and remove the Cartesian coordinate system and just put in Rn in place of it, just make it look nicer. in the case of the tangent bundles, they have the same dimensions, so therefore this r is going to be r to the 2n as opposed to r to the n plus m. Okay. All right, so next it'd be nice to get a function that can map an element x in here, some x, into the r to the n plus m, the product space. So that function is the same thing as going back inverse psi 1 here. So I put inverse psi 1. And from B, there should be a section sigma. They go from U into W. So I put sigma right there, composite sigma, and then composite that with W. So that should be the same as going from here, from the left, from Rn to Rn plus M. So let me rewrite this. Omega composite sigma composite psi inverse 1 is a mapping of psi 1 of U into the R to the N plus M. And then on this side, it's the same thing. We want to get it would be nice to have a mapping from Rm to Rn plus M. So go back here. So you would go inverse side 2. And then I'm going to put in the insertion map. So let's see here. It's going to be IP downstairs. Yeah. So essentially, IP composite PR2 will give you the identity. Okay. So I'm going from inverse side 2 to the insertion map IP. So yeah, put -1 there, inverse. And then inverse phi, because phi is a homeomorphism, so it has an inverse. And then the last step is to write down what W is for that side in W. So that route will go from Rm to Rn plus M. So you could do the left-hand side or the right-hand side. It will give you the same answer. So the right-hand side here will be a mapping of psi 2v into R to the N plus M. So let me just write down psi 1 is a mapping up from U, subset of B, into Rn. Psi 2 is the mapping of the fiber V, subset of F, into Rm. And then the homomorphism is going to go from the inverse of U, inverse projection, bundle projection operator of U, into U cross V, subset of E. And then W, which is open subset in the total space. So it's just the preimage of the homomorphism of U cross V. Which of course is it's a subset of the preimage of U cross F, where F is the fibers, because V is a subset of F. And that is the bundle projection inverse of U. Okay. And of course, that is also a subset of total space E. Okay. All right, so we're going to work on the omega composite sigma and psi 1 inverse. But we're going to restrict that function, the section, to just the domain of U. Okay. So this is going to be mapping from all the way down from Rn into Rn plus m. So remember, psi 1u into Rn plus m. So let me look up here just to make sure what these things are. So I need to write down what W is for another route. So W can also be replaced by, if you go from to the top, which is a homomorphism, and then projection 1 down. So homomorphism first, composite that with the projection 1 to get you back to U, and then psi 1, which map down to Rn, and it's just psi 1. Let's see here. Yeah, so just composite psi 1. So what I just wrote down is just the first part of just W. So I need to plug this W back into this function over here, so that we could go from Rn to Rn plus m. So let's see here. Yeah. Yeah, let me think a little. Hmm. Oh, I see. Okay, so the projection 1 operators and phi is just equal to the bundle projection operators, because the diagrams commute. Okay, so let me rewrite this. Omega, sigma, sigma. Sigma is the section from B to M, restricted to just U. So the left-hand side is analogous to f of a from the previous topology theorem that we proved. And then I'm plugging in for what W omega is. Omega is psi 1 composite PR1 composite V composite sigma, the section restricted to U, and then composite psi inverse of 1. And all that is acting on an elements in Rn, so that's X. So all of that right here, what you see here is F1 of A in that analogous to that topology theorem that we proved. And then F2 of A is what I'm writing down here. It's going to be psi 2 PR2 of phi restricted to U Okay, so all that is the left hand side is acting on X, and the right hand side is an elements of the R to the N plus M. So let me rewrite this. Psi 1 inverse. Let me check something. Okay. So you see here I'm using the omega composite sigma composite psi inverse 1, but you could also use the other one, the one on the right hand side, and it should give you the same answer. And I encourage you to try it. Okay. So we know that from the diagram, projection 1 composite phi is equal to the bundle projections because the diagram commutes. So I'm gonna write that down here for you. And also pi composite sigma, which is the cross section, is also identity to B. So all this here is going to collapse down to just psi 1 composite pi, and then composite sigma restricted to U, and then composite to inverse of 1. And on the right hand side, it's just you just have to write down whatever you see there. I don't see any contraction on the right hand side, so that's fine. Okay. Okay, so now the left hand side, the first components on the right hand side is collapsed down to just psi 1 composite psi 1 inverse of X. And then the right hand side is just psi 2 composite PR2. And then go up to composite phi, and then composite sigma restricted to U. So all of that there is a big object, but you could just think of it as a coordinate transformation for the second components. Okay. So this is the induced part. Is the one that the big blob on the right hand side on the second component. So psi 1 and psi 1 inverse collapse to just X. And of course, remember X is in Rn, so that should be Xi, where I is going from 1 to N. Okay, so the second components on the right hand side is just like a coordinate transformation. So you could let it equal to be anything. You could let it equal to be y of mu or something, mu of x if you want to. Where mu is going from 1 to m. Remember, this is the components of the fiber. So therefore, I have xi, where I is going from 1 to n. and then the Greek index mu is going from 1 to m. Okay, so y mu is what being induced. Well, xi and y mu is what being induced in the total space. Okay. So let me rewrite the function going from Rn to Rn plus m. So xi is being mapped to xi comma y mu. And this is what we mean by induced functions, induced chart on the total space. So the next thing we're going to do is we're going to replace this with the, oh, I'm going to add something more here. So let's call this thing here PR1 prime to distinguish it from the top PR1. And there should be a PR2 prime here too. And then of course you could have omega 1 going straight from W to Rn, and omega 2 is going from W to Rm. So this is in line with the theorem that we proved in topology from the previous video. And omega 2 is, and you see here the diagram should commute because omega 1 is going to be omega composite PR1 prime. Okay. So what I'm writing down here, omega of E is analogous to f of A, equal to omega 1 is f1 of A, comma, omega 2E is f2 of A, from the theorem from topology that we proved. And then from the diagram, you should see that omega 1 is going to be PR1 prime, composite omega. And then omega 2 is PR2 prime, composite omega. And we know that omega 1 and 2, omega 2 are continuous because, well, you could check that they are open, so therefore they are continuous. All right, so this picture here I'm drawing here is in place of the total space E, I'm going to put in the tangent bundle TM. And again, the pi projection map is onto U, which is a subset of M now. Before it was a base manifold B, but now it's M. And then you have the homomorphism going from TM to U cross V, where V is just a fiber. In this case, it's going to be a subset of Rn. And then, of course, I have the two projection map, PR1 to U, PR2 to V. And then here, I have psi 1 is mapping from U to Rn. And then, of course, the mapping from Rn to R2n in this case, because the fiber and the base manifold has the same dimension, so therefore you have 2n as opposed to n plus m. And then the mapping from Rn to from the fiber to the products is going to be psi 2 inverse, and then insertion map is IP, and then inverse homomorphism phi inverse, and that should get you back, and then you should composite with W, so that should get you back into Rn. Okay, so psi 2 inverse, composite insertion map P, and then go down inverse phi, which is the inverse homomorphism. And then finally hit it with omega. Okay. So you could think of the left hand side is omega 1 and the right hand side is omega 2 if you want to see it in line with the topology theorem that we proved. So just like before, I'm going to write down the mapping between Rn. So this is Rn into R2n. All right, just like before, this omega here, the left hand side here is kind of like the f of a, and then the right hand side will have two components. So this side here is I'm mapping from the fiber, which is also Rn to R2n. So the top one is mapping from the left to the middle, and then the bottom one is mapping from the right to the middle. I'll leave this for you to do as an exercise to show you that this is give you the same result. And the element E of the total space from the previous generic fiber bundle is replaced now by V sub P, where V is the velocity and P is the point of application. Okay. So here I'm writing down something that is analogous to the theorems that we proved. Okay. All right, so here omega composite sigma is a section from B to the tangent bundle, tangent space. Composite that with the psi 1 inverse x. So what I just wrote down is equivalent to like f of a. Okay, the left hand side of this equation. So there should be two components on the right hand side here. The first component is going to be psi 1 projection 1 phi. So that's just omega. Okay, psi 1 p1 phi is equal to omega, and then composite that with the restricted section sigma on U, composite psi 1 inverse of x. And then the second component is going to be well, you can see here there's many paths to go. You can try any path you want to, but I'm just going to go to the one that I use for the generic fiber bundles. Okay, so I know that psi 2 is a mapping from the fiber bundle, but in this case it's going to be Rn. So psi 2 projection 2, let's see, yeah, projection 2, and then composite phi will get you to W, and then you cross that with the with whatever you see here on the bottom here. Yeah, so that is, so think of the second component is omega 2 of V of P. Okay, now just going through the algebra, and we should see that the first components will collapse. PR composite phi is just equal to the bundle projection pi, and of course pi composite with this restricted section will give you an identity on U, and then the psi 1 composite psi 1 inverse will collapse. So the only thing you get is just an element in the Rn. from the left here. So x to the I, where I is going from 1 to n. And I see here that this phi and this inverse phi here is going to give me an identity phi inverse. So it's going to give me an identity on the tangent bundle, TM. And then what I have left here is side 2, so that should collapse to, let's see, PR2 composite IP, the insertion maps. So that should give you an identity 2. And then of course side 2 composite side 2 inverse should collapse, so that should give you just V, which is the components of the velocity on the right hand side. So the only thing you see have left is VI. Notice the index is no longer Greek. It's same Latin because they have the same dimensions. So both i's going from 1 to n. So therefore the products will have dimensions of r to the 2n and a proof. And I encourage you to try the other path too. Let me check here. I think looks good. Well, that was fun, guys. I'll see you on the next one.